Okay, good afternoon, everyone. Thought I'd take this opportunity to answer some of the questions that I've had sent to me via the Ask My Instructor function. So this is a good question from chapter 7, right? Whenever you have how many people must you survey, that's going to be a sample size question. Assume that you want to be 90% confident. So again, related to confidence intervals, they give you the error and so on. Assume that nothing is known. So this is a good question because there's a couple reasons this is a good question. When we don't know anything about the sample, we're going to assume 50-50. This is just like the concept in chapter 10, where if you don't have a significant correlation, you simply just guess the average, right? If you don't know, you say 50-50. How many? So in this case, that's fine. We just go to our formula sheet. And that's even mentioned there on the formula sheet. Chapter 7, sample sizes. So if you know what they are, then you would use this. If you don't know, you use this. It's the same thing. I mean, if you assume 50-50, then you get 0.25. So it's not a big surprise here. But this is the formula we'll use here. So our sample size is going to be, well, we don't know the Z alpha over 2 because we haven't looked at that yet. We know this is this. And we're going to know the error because they told us, right? They said 3.5 percentage points. So percentage points percent. Again, remember in mathematics or statistics, percents are always decimals. So we'll put that in like this. And now we need our Z alpha over 2. So the best bet with these is always to kind of do a little sketch. I believe it said 90%. Yeah, 90% confident means that you want the middle 90, right? So I'm interested in this Z score here. Another way of handling it is to go like this. Well, the uncertainty, if the confidence is that, the uncertainty is this. Alpha over 2, because it's two-tailed, right? Says, let's find a score that corresponds to that. Right there, 1.645. And we're done. .552.25. Because this is a discrete value, you have to say we need 553 subjects. Always round up. And that looks like it's the right answer based off of this. Right. Assume that a prior survey suggests that about 37% prefer an aisle seat. Well, in that case, then you just change your P and your Q value, so everything else stays the same. I'm just going to change .37. Right, the only thing that changed there, in case you're not following along there, is we know the initial proportion. So this is a great question because you'll be seeing that throughout your careers. You know, do we have an idea of what's going on or do we not know? So if you don't know, you use this. Right? If you don't know, you assume 50-50. If you do know something, then as you're going to see, it's a smaller sample size because you come in with prior information. Right? If we have information, it's more valuable than if you don't have information, which is a major theme of this course. So let's just switch this up. By 14.9, which is a smaller number. So that's a nice little lesson there, is that if you have some idea of what's going on, you're better off than if you don't. We need 515 subjects or data points, whatever you want to call it. Okay, great. All right, use the sample data and confidence level given to complete A through D. Research Institute asked respondents if they felt vulnerable to identify theft. That makes sense. So here's your sample size. Here's how many said yes. What's the best point estimate? So we got that one. The point estimate, just to review there, the point estimate is whatever the sample says. So the point estimate is always, so this is something from chapter 7, whether it's means or proportions, always indicates what does the sample say. So in this case, you got it right, because that's going to be 526 divided by the sample size. Right, the point estimate in this case is going to be x over n. .480. There it is, 0.480. So that one was correctly done. Identify the value for the margin. Okay, so again, here, all we really have to do is worry about the Z-score. Right? What's the error for these things? It's going to be Z alpha over 2, PQN from the formula sheet. So what's the Z-score for 99? Again, it just takes a little bit of practice, but eventually you're going to realize that's a common number. Right, 99 would mean I need 0.05. Not that, that's going to be, no, I need 0.005, right? Yeah. 2.575. Nope. 2.575. 2.575. Again, how do I know that? Sketch the curve. And you say, all right, well, 99 means that the rest has to be 1%. So it's going to be a small error because the sample size is so big, right? Anything over 200, you're going to get a small error. So 0.0389. And again, just make sure that the, 3 decimal places. Ooh, so 3 decimal places would be 0.039. What is the confidence interval? So we just keep going here, right? So if I have the error, but we've done the hard part, right? For the confidence interval, it's the point estimate plus or minus the error. So the point estimate of 0.48 plus or minus 0.0389. Right, so on the low side, it would be minus that, and then the high side, plus that. $0.441. Then on the high side, $0.519. One has 99% confidence that the sample proportion is equal. Nope. There's a 99% chance that the true value will fall between maybe. One has 99% confidence that the interval from the lower bound to the upper bound actually does contain maybe 99% will fall between the lower. Those are all pretty good. What's the difference between these? This is a tough one. There's a 99% chance. Well, these are both pretty good. I don't like either of these. I mean B and C. I'd give you both on the test. Actually, I'd give you D too. That's pretty close. Yeah, I mean, it's really hard to figure out what's the difference between these. I think it's 99 times out of 100, it falls between them. One is a 99% confidence. Well, there we go. I'm gonna go with this one. But again, this is tricky. I'm basically guessing, but I think 50-50 here.